working on modifying some database tables that we created yesterday through the ETL process, checking them for errors, and maybe writing some validation tests so that in the future this whole process of ingesting the data, putting it in the database, and modifying and cleaning it in the database can be automated. That's kind of the goal of mine. I'd like to be able to rebuild the database when I need to without having to pay attention to it closely myself. So that's kind of what I'm going to hopefully be doing. And I appreciate you joining me this morning. So we're off. Yesterday, after I did some exploratory data analysis on the arrest data, I loaded that data successfully into my database, and I have a database table now. I have two database tables related to the arrest data. One includes the data on the actual arrest, and the other includes attribute data about the entities that did the reporting themselves, the agencies, police agencies. That data is smaller than the data on the arrests themselves because there's only one row per agency per year, and I already have data that kind of fits that format of one row per agency per year stored in my database that's linked up to my clearance data that I worked on a couple weeks ago. So what I'm going to try to do is reconcile the agency attributes from the arrest data with the agency attributes from the clearance data. And that's going to be useful to me for a couple reasons. The first reason is that there are a few years where they overlap. So hopefully that data is identical in the years that they overlap, and then I can reduce duplication of data in my database. There are some years where they don't overlap, and so then I can use the entity that, or the data source that provides the data, to extend my data series by filling in the data that would otherwise be missing, because I can use it as another source. So I'm going to use these two sources, and I'm going to try to get basically time series of data from 1980 to 2015 between them that is the same uniform sort of data. And it's a lot of metadata about the entities themselves, but that data is going to be really useful to me for being a source data that I can link the police agencies to other variables about the communities that they serve, which will be useful when I want to go and actually model the data. So the idea of reconciling this data, this is another one of those things about foundational elements that I have to get focused on before I can move to the more exciting parts of data science, like making models, building predictions, and evaluating my predictive models. I have to make sure that the foundation is really strong, and here the foundation is that I have trust in my data sources, and I'm not having conflicting measures of the same thing. I know which one is the better measure. So that's what I'm going to focus on right now. So I have, let's see here. Okay, I have two tables, agency year and agency year arrest, and I've pulled in the entire information from both of these tables. My goal is to drop one of these two tables and combine the best parts of these two tables and have just one table called agency year. So what I need to do first is find out if where the same year is covered by these two tables, if those data attributes are identical for those 2 years. So I've written out here that I think that the following fields are likely to be identical between these 2 years. So I'm going to write a little test to tell myself to find out whether that's true. I'm going to iterate over the years, and I'm going to say vector AY data agency count, where AY data year equals I, identical to vector AYA agency count. I'm actually going to do RI code. Now we can see that none of these are actually identical with each other. So now the question to figure out is why. They look similar. Are they the same class? They're the same length. That's good. Same number of unique values. So now I'm going to have to ask myself, or ask what values appear in one that don't appear in the other. So I really should write a function to do this eventually, but about that later. So this kind of unwieldy statement says, give me the values of AYA ORI code where AY data year equals I, and then only return those values where AY data ORI code that year does not appear in AYA data ORI code in that year. How about give me those do appear? All of them appear. So then the question is, they're all there. Actually, the problem is going to be that they're either they're not sorted correctly. And that's interesting because I did sort them. So the next thing to check, because they really do need to be same order, I think. The next thing to check is maybe go line by line and see where they are or are not identical. Like, Guess what I can check now. I'll say little typo there. Go. Are identical. So I probably should have given these more distinct names so it was easy to spot a typo. Whatever, that's how it goes sometimes. Let's see. I won't have this problem. So we know that state and ORI code are identical. That's great. Be happy about that. Number identical. Now this one I think is not going to be identical because I think slightly different wording in the two data files. It's in each year when they coexist, they are actually identical. That's really interesting. I'll make a note that I need to clean up the names. That's going to be something I do separately. Year is identical. Got that. Or city indication. Identical. Now these should be identical because a lot of times these fields were sourced from the agency year table when I built the agency year arrest data. So I'm just confirming that that's true, keeping with my mantra of slow data analysis to try to build my fluency and foundational understanding of the data. But the idea is that I'm going to drop the things that are duplicated and work on identifying a way that I can condense these two tables into. So that's going to be a crucial aspect to this work. for the years that they overlap, just confirming that they are identical. Next step will be to make sure that the years where they don't overlap, if there is data in one and not the other, that it has a similar format and similar expected values. To the end of these. So now it's going to be a little bit more tricky of a test. So I can't just test whether the vectors are identical. In 1997 all the way back to 1980, I don't have any AY data. I just have AYA data, agency year arrest. So I have a subset of the attributes, and I tried to store them in the same names. And the key here is I need to make sure that they're formatted similarly. Got a taste that they're not from looking at the names of the divisions up above, but let's just take a peek here. There's here I can see an error that in 1984 I reported that every single agency was a U.S. Park State Police, which is not correct. Go back to my ETL script and fit that. I wonder what raw data. Let's be coded. So to check coding on this variable in years prior to. That's one issue. I can't just copy forward. Let's work my way back through these. So what I want to check for is 87. See what percentage of these ORI codes show up in future years. So call this keys. It's going to be all the unique ORI codes that ever appear in the clearance data. 22,000. So I'm going to say wrong enough. So it looks like these are substantially the same. There's about as much slippage as we would expect from agencies stopping to exist and starting to exist. So I can assume that this vector is pretty solid, which is good. So there's all the state codes there, but none of the states. So easy thing to check, we'll say interesting. I didn't bother to store the state attribute. So that's actually probably okay because the RI code and the state can be linked. Yeah, I can extract the state from so state code exists, but no state name. That's good. So then the strategy the group number looks like it has similar things but different names, so it needs some recoding. To do code to be consistent. Oh, same thing. I don't need to go. I don't need to run the test for division to know that. All right. These maybe actually have different definitions. Just looking at the, in 20 years, there's only 6,747 city entries, and in fewer years, there's more core city entries. So I mean, I'll before I collapse those, I want to check the definitions. Covered by code, that's going to be really tricky. should be somewhat variable. But there's a problem. Looks like all of the covered by code entities, which are entities that report on behalf of a different ORI code, they all exist throughout the data and every year. So that's good. You can stack that data on. Just see, I bet this doesn't exist. It shouldn't exist actually. So if I look by year, it should be true every year up to 1998, which is the case. So fine. Field office does not exist either previously, which is also good. This one is correct. To do fix coding in each values coding as US Park State. It's actually because of the logical sequence. That'll fix it. I already population. So let's check out the counties. That's probably the next one we need our key test with. Like there's something wrong with this data because why are there only 6 unique values of county? But the coverage looks pretty good, so if there is something wrong, it's wrong in both of them. Same, say. Say they're all constant. That's also very good news. Good news. Alright, this one's going to be a real test. Agency name. Should match up with ORI code, but of course there's going to be more probability of inconsistency in the way the agency name was keyed in over the years. But it has a pretty good match rate. It really spikes up. No period. It's really good. I'm not going to worry about state name, state code. State code. I don't need to worry about state name because I'm going to build a table that matches state code, state name, and other state attributes. And for those who've been staying tuned regularly, the squirrels are back outside my window. I'm cam out there so you guys can check them out sometime. It's pretty entertaining. State code quick. Great. No formatting changes there. City sequence. This is an odd. Check it out. Looks like prior to 1981, city sequence number, strange beast. So I'm gonna check that out. Yeah, I padded it incorrect. Check out this very prior to 19. Anymore. Fixed it. Correct. So what does this add up? The key is that for the places where I feel like it's identical enough, I can use AYA data. And the advantage of that is that, like I said, the AYA data has a longer time series. So wherever they line up, I just use the AYA data. And I just need to patch up the AYA data in a few places, but otherwise that can now be my canonical source of information for the attributes of these agencies. It can be the canonical source I use for matching this information. And because of that, I can probably just keep one of these tables in my database and discard the other one. And then I can do my data cleaning and stuff based on that. And that's going to be advantageous to me because I don't want to duplicate data in the database. I want to have one source of these ORI. That's what I'm going to call them. They're police agencies that report to the FBI. The ORIs, I'm going to want to have one table that tells me everything I need to know about them, and I can link all of my connecting data, whether it's the crimes that occurred in the ORI, the arrests that the ORI made, or whether it is attributes about the community that the ORI covers. The tables will all link to just one table that tells me about each ORI in each year. So for example, I know I can toss out the AY data ORI code. It's going to be identical. In the years that I want. Need a fixed group number to be consistent. Because none of these values appear in they're just coded differently, so that's pretty easy to fix. They're the same category, just abbreviated separately. Same with division names. Covered by code is good. These two don't exist in the AYA data. Agency count is solid. Population, county, MSA, agency name, agency state name, state code. We're all solid. City sequence number is close except for 1991 forward. So I can pretty much toss out AY data whole cloth because I've already bound AY data onto AYA data. So that's good. I don't need to do any other work. I can probably just drop the table, and then after I drop the table, rename the other table to agency year. I should be able to use these same queries to construct the flags at the end of the AY data. And I should be able to create some additional flags now using the arrest data and creating some flags for the years prior to 19, which I think is also really good, useful. So that's probably my main task for the rest of the morning is to go through and do a little bit of this recoding and then drop the table. Then I'll have the one table that I need, and then I can go back to my EDA on the arrest data, which is good. And after I do some more EDA on the arrest data, then I think I should be at the point where I need to start bringing in some covariates from other sources. So that would be census data, etc., to merge onto the ORIs. I think because I built this in a PostGIS database, it actually should be pretty good. I should be in pretty good shape for that to work. So I'm gonna actually, because I'm curious, I'm gonna read in this city code, see what's wrong with it prior to 1991. Which I don't need to do that. I can just look. I wonder if in the raw data this is somehow shouldn't be. Shouldn't matter. Or why, yeah. There's NAs cropping up, and it might have to do with forcing it to be a character or some other way that I'm doing it. Luckily, I can actually send check it. So know that this should be a year prior to 1990. And I'm just gonna read in. Check the year, and see what's going on. $1989, great. Does it have a different, its name is sequence number 5-digit. Oh, and then I renamed city sequence number, which is good, okay. But it is blank for 5,497. So it's just maybe that in prior to 1991, it wasn't really reported. Oh, well, that's good. It's just it's not recorded. I can consider whether I want to fill it in from the other data that I have. Like I can take a random RI. But it looks like the city sequence numbers for this ORI changed between the time period that flipped. Maybe they all changed. Let's look at. I wonder why I padded these and be 5 digits. Guess because it tells me they're 5 digits. So maybe I was enforcing that, but I probably shouldn't do. I probably shouldn't do that. Let's see. All right. That seems like a pretty good from the stream, I think, because now the rest is even more tedious than what I've been showing. And I'm just gonna take a little walk, give my eyes some rest from the screen. I'm gonna figure out how to reorganize these tables and implement that while and computer rebuild the tables while I eat some lunch. So I think that's gonna cover the live stream for this morning. But looks like tomorrow's live stream will be exploratory data analysis, maybe some imputation. I think I'm going to be doing imputation from here until probably the end of the month, and also importing covariates for modeling. So I think, end of the month I should be fitting some models and starting to get some results to then go the prime time viewing for the stream, and hopefully I'll be more polished as a streamer by then. So thanks for tuning in. I talk to you later this afternoon, or I'll wind up talking to you tomorrow. Bye.